Hey everyone. I'm giving the lecture today on the canister interaction and the different ways you can do that using, well, so there's the command line, there's candid UI, um, there's canister to canister calls, and then finally you can actually use JavaScript as well, which can be the front end of a lot of your guys' projects. But yeah, so we're gonna start with the command line. Um, so yeah. I'm gonna give so what I've kind of noticed is a big problem with I guess canister interaction at the command line is really just getting the syntax down and figuring out like, oh, I have a text type. How do I format it? And it seems like occasionally, I don't know, there wasn't like a resource, and I wanted to show where in the documentation it was. So I'm gonna paste in. I guess you can follow along with some types. Like canister call types. So I'm going to paste it into the chat right here. And, right, 1 second. Doug, my bad. All right, so yeah, we'll walk through this. So essentially, I have a canister and I have like a variety of functions that take in a certain type and really just return the same thing. It just takes the parameter and spits it back out. But yeah, I'm gonna do this with a record type, text type, and array like an array of opt nats, natural numbers, and then a record of the type we made, our custom type, and then blob as well as a principal ID. So yeah, I think this will be helpful to show you how to like map everything. So first off, we'll start with the simplest thing and kind of how to go about all this. So let's see. We'll start with type text, right? Of the supported types. So as you can see, how this works is corresponding Motoko type says text. And that's the type we're going to take in, and we're going to spit it out, right? So now you're probably curious, how do I match this up with Motoko? I mean, sorry, with Candid, or no, the terminal. And you go to something that says textual syntax, right? So this right here is like the golden like key for all types, and you'll see why. So I'll just start here. So we're going to do dfx. Oh, actually, I did want to mention for some of you, when you're using an actor class, how to call it like with arguments. So I just made one of my actors actually have an argument. So we're going to dfx deploy dash argument. And then let's see, it's just 1, 2. And we'll just wait. All right, and then I'm gonna clear this, and I'll show you how this works. So dfx canister call, then you're gonna type in again your name of your like what's it called, the canister name. So mine is slide 1, as you can see when I kind of put my mouse there, and then I'm gonna also call the function. So it's gonna be slide 1, and the function is return text, right? Return text. And then, so now it's like, how do I know what to put in here, right? You're gonna go to textual syntax of that type you have, right? So if I have Motoko type text, I'm gonna match it up here, and I'll see the format. It's just like this. So it's gonna be hello, and then I think I have two inputs. So it's gonna be hello, and then like ABC or something. It's just garbage like things, but inputs. But yeah, as you can see, so it matches up for the text. Now that's the simplest case, and I use that just because I'm sure all of you guys already understand text. But some of these other types are like, what do I do? And yeah, so this will kind of match it up. So here we have uh, a natural number with an opt type inside of an array. Now, how does this work? So maybe we could start with natural numbers, right? So let's say, okay, yeah, we go to nat for Motoko type, and then we find the textual syntax, right? This is going to be 1, 2, 3, 4, just random numbers. It could be a hex or hex, and then some other format. That's like binary or something. And then, so we're going to call that one now. So dfx canister call slide 1. Let's see, return opt. And then, so now we're not done though. We found the number, but we also need to figure out what to do with ops and what to do with the array. So then we're going to go to opt t, and at this point, I'm assuming you know question marks are related to ops when you see that in Motoko. I guess that's something like I assume that you would know. So as you can see, it says opt. So if it was a nat8, it'd be opt8, right? So you go down again to the textual syntax and map that up. And then the final part is arrays. So, or sorry, vec. And those correspond to, as you know, like the brackets. Those are for vecs. So, or arrays. So we're going to do type vec t. And as you can see, we go to corresponding Motoko type. As you can see, it says bracket t, match up with textual syntax. So let's put it all together. We had, so it on the outside, it's going to be vec, right? And then it's going to be an opt. And remember, ops are different than, or natural, or ops before, and ops of natural numbers are going to be different than natural. You can't just put like 8, right? You have to put the opt 8, and then it's going to be this, then opt 9, and then close and run it. And ta-da! So I've given you like I guess a key to figuring this all out, hopefully. And then let's do, I don't know, you want to do, let's do records, blobs. Oh, we'll just do them all real quick. Yeah. Or actually, no, I'll skip down to principal, just to save time. So principal, type principal. All right, so how am I going to figure this out? Corresponding Motoko type. Oh, well, it took in a principal, right? So actually, this might throw an error because I didn't import principal. But let's see what happens. Maybe I did. I'm just not. Or it's an inbuilt. Oh no, it's a primitive. It's a primitive. That's right. I was thinking I had to import it. But okay, yeah. So that's a principal, and then we're gonna do what's the corresponding syntax to that? So it's this right here. So first I need to get my principal IT. So dfx canister ID slide 1. All right, and then could actually call that function again. So it's called return principal. So I spelled it wrong, but it's fine. dfx canister call slide 1 return. Oh wait, no. Yeah, return principal. Then you're gonna do it, write it just like how it does in this thing. And so after you put the little brackets, right? So it's gonna be print or so print principal. And I'm gonna do that like a text type, and then bam, it's gonna spit it back out as a principal type too. So not just a text type. And there you go. There you go. So I'm gonna move on now. I think you can map everything else out yourself. So the next thing is Candid UI. So I'm gonna paste this here. Then yeah. So yeah, the next way to run this is, or like test or interact with the canisters in Candid UI. And you can find your Candid like interface by typing in dfx canister ID Candid UI. And then they're gonna, they have the instructions, but essentially, I already did the dfx start. That's how this whole thing's running. But yeah, you're just gonna do what they tell you here, and so copy and paste this, and then yeah, and then you're gonna choose your canister ID. So let's just choose slide 1 again, and then yeah, and here's like your interface for everything. And just to save time, I guess I've gone longer than I'd like. I'm gonna, you know, skip this, and I mean, you can type in like whatever, run it. So yeah, yeah, the next part is actually canister to canister calls from another canister, and I actually wanted to type this out, like, so you could see it live. Here's one resource. This is the example they give using Connect, like that linked up app in the documentation. And then this is kind of like the way to do it outside the network. If we have time, maybe I'll go back to the network one. But yeah, just show. So let's see. Okay, let me. So I have a canister that I called slide 2B, right? And basically all it is it has a private variable and a method to update this variable. And I don't think it's 9 anymore. I've been running it just to test, and it's probably some like big old number. But the point is, I actually wanted to retype this out, and yeah, kind of walk you through everything. So the whole point of this is for one of the canisters to do these 3 things. It's going to call this method. It's going to also get the principal ID of this canister, and then it's going to call this function, but not through an import of this canister, but it's going to call it by putting in this principal ID. So it's a whole different like concept, I guess. I mean, it's the same. It's doing the same thing, but I mean, it's like one is you're actually importing it from yourself, and then this method is like, oh well, someone else created a canister, right? If I knew their ID, I could actually call it and run it. So yeah, let's do that. Guess I'll just type it out. So well, first off, I actually let's just say I imported slide 2B. So that's that one, that actor. And then I'm gonna first create the function called increment slide 2B. So public increment slide 2B, and I'm gonna take a number, and let's see, a natural number, and then so as you can see, maybe I should have showed this first. Yeah, it's gonna take a natural number, and then it'll just update it. So yeah, and then I'll actually return a natural number as well. So far updated number, equals await slide to B dot update. So it's called update my var. See, if I switch over, so update my var, and then I'm going to put in num. Then I'm going to return updated number, and then G equals G. All right, I'm going to save that. And in case you can't see, this thing saves. It's like a quick command in my workstation. So dfx, I got to deploy again. So well, I'll just do a quick deploy. The history. Okay, I'm missing a semicolon or something. Let's see. Public, oh, this way. Make sure no errors. All right, so all canisters have been deployed. And also note, this was from the previous part, not for slide 2A or 2B's canisters. But I'm going to clear this, and then I'm going to call the first function. So it's called increment slide 2B. I'm just going to copy it real quick. Copy, and then it's dfx canister call slide 2. Is it slide 2A? Yeah, slide 2A. Slide 2A. And then update slide 2B, and then it's going to be this. Like, we'll increment it by 5. I'll increment it twice just so you know it's incrementing. And I might have typed, yeah, it's not update slide 2B. Let me just copy it. It's called increment slide 2B. Paste. All right, that should work. All right, right now it's at 27, just because I've been running it, and I'm not going to go through all the upgrading stuff and like reinstalls. And I keep running it. See, now it's 32. Now it's 37. So yeah, you can see that what it's doing is it's calling slide 2B. Slide 2B is going to return my var, right? It's going to return this private variable, and then slide 2A, active slide 2A is actually going to spit out that updated number from slide 2B. So now I'm going to clear. Now we're going to implement the get principal ID of the second active function. So I want to get the principal ID of slide 2B. So how am I going to do that? We'll start by creating another method or function. That's the same. So public func get principal from slide 2B. Or I'll just put active. And then you're going to do, don't need anything. Sync principal. And then, draw. So now and let's see, you got to go to the principal documentation here, and I'll tell you how, like there's a function from this module called from actor, right? So if I import slide 2b from into slide 2a, the actor slide 2a, then I can put in here and it's going to spit me out a principal ID. So yeah, we're going to do that. And by the way, so this is the import. So this right here is the actor. So it's going to be let, or no, I'll just return it straight off the bat. Return principal dot from actor. And then what are you going to put in it? You're going to put, well, the actor, right? So slide 2b, slide 2b, and we can run it. And then I'm going to show you that I saved it by full screening just for this one. So yeah, the dash deppy. Then I'll let it kind of sit here. I think this will be on YouTube, so you can pause it if I go too fast. Hopefully I'm not. And then we'll run that function. So it's going to be dfx. Oh wait, we have to deploy. So dfx. Yeah, I'll do a fast deploy. Just running through my command line history. All right, so deployed canister. So I'm going to get clear, and then we're going to run that one. It's going to be, so this guy right here, just copy it. And then dfx canister call slide to a, and then function get principal from actor, and I think it doesn't need any parameters. And there you go. So just to check, we want to check what slide 2b's canister ID is. We can do dfx canister ID, and then slide 2b, and there you go. It matches, right? So, and just so you know, there's no trickery. It's like if I type in slide 2a, it's going to be a different one. But okay, so the final thing is going to be calling this function, but not from the import, right? You're not calling from import. You're going to call it by typing in its principal ID. So here, it's going to be public func call from ID, and then we'll do canister ID text. Oh, you know what? I should say where I got this. So this isn't anywhere in the docs, and it seems like, I mean, this is so like we're all like early for development, just because things are still like being created, like even like methods for yeah, I don't know, like calling canisters and stuff. So this link right here was where I got that, and if you want to look at it with me real quick, I really just copied this guy's method, and you can take some time to, I suggest taking a look at this, and this will actually allow you to call canisters not just locally but through the network, because this is actually a network canister, but I'm just doing it locally. But yeah, so what you're doing is it looks like you're just taking the actor, then you're gonna type in whatever methods they have and kind of format it, and then you're gonna call that method right here, right? So it took a text, and then after you, I guess, imported that actor via principal ID, you call that, and always remember the await. And yeah, I might actually, if there's time, I may go back and talk about that, like for the network use case, but that's fine for now. So df public func call from ID, async, and then it's gonna return a natural number, right? It's gonna spit out that, and bracket. Ooh, I do suggest GitHub Copilot isn't for um Motoko. Like I haven't found anything, but I do code in C++ and it's pretty helpful. So if you have a chance, like try to join the beta. I mean, it does some stupid stuff like that too sometimes. And it makes things actually a bigger pain. But yeah, I suggest you look that if you're curious why it's doing that. But okay, so we're gonna do let canister too. So we're calling equal actor canister. Yeah, see, this is when it becomes a problem. Canister ID. So we're putting in the canister ID in here as the active, and then we're gonna like get the methods from it. So it's gonna be update my var. Then it takes a natural number. This thing formatted. Update the updated var, and you're gonna put in a natural number, and then it's gonna be async that, right? Okay, there you go. Now, so this right here is like a canister itself. So it's like you're importing it via a canister ID. So now we're just gonna call, so it's like doing this almost. Yeah, basically here's how to say it. I'm doing this, but with the ID. So yeah, you can interact with the entire network, which is cool. So any canister, and you're gonna do return await canister 2 dot update my var, and then it's gonna be, we're gonna want to put a natural number, right? We're calling update my var from that slide 2b. So let's just say we'll update it by 10 or something, right? All right, hit that, and then go here, and then deploy. I'm not running. Oh, I'm running a little slower, but I'm basically done after. Well, I'll have to show you JavaScript too, but I was just gonna like copy and paste from the doc. So to be honest, you can probably figure it out. And then I'm gonna hit clear, and we'll just run it. So dfx canister call. What was it? Brain fog. Slide to A. No, and then the function is gonna be called call from ID. Call from ID. ID, and then, oh wait, crud. I need to get the canister ID. I forgot. So dfx canister call ID slide to B. Oh, oops. dfx canister ID slide to B, sorry. And then copy that. And then we'll go dfx canister call slide to A, call from ID. And then you're going to do this guy. And oh yeah, remember that type was text, so we got to put in the text. So bam, 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 hit it. And right, it's incrementing, it's incrementing, it's incrementing. Okay, so yeah, that's that's canister to canister calls, and then finally for JavaScript, just do this quickly. I'll paste it here. And then paste this here. And then, so the default, like the default, like front end looks like kind of like this. Let me just start it for you, and you'll see what's gonna happen. I don't know. This is just gonna be a demo. I'm not really gonna teach you, I guess, because we're kind of out of time. But yeah, you can see what happens. And then, oh yeah, this did I? You know what? I don't think this is right. Restart. That's fine. Well, you access this with localhost 8080. Right. So I typed in npm start here. So it's npm space start, and then I go here, and so what I did was I changed the like import and to slide one, and then I also had to install something called Principal, which allows you to use Principal IDs in JavaScript, like from text. So yeah, and then down here is the function. So this is like the literal default like front end asset. So it's not like a change. I literally just changed the greeting line so that if you type in canister ID, well, I actually hard code it, but I'm gonna change it to allow you to put in a variable. So refresh this, and I actually, so we're gonna get the canister ID, the effects, canister ID slide to a, or what is it? Yeah, there's slide one. So this is from the function from slide one where I call get principal. If you want to like map it out, you can take like a screenshot if you're watching, if you rewatch this on YouTube or something, and how it maps out. It's slide one that return principal, and then you do principal dot from text, and then whatever you enter. So I'm just gonna paste. That's not my principal ID. Oh yeah, that is. And then click, and it's gonna print it out. See, so yeah, that's it. And yeah, so I guess to relate everything back to that candid, the documentation really, this tells you what doing it into Java. If you're, that's the only thing. You have to do something called npm install this package. So I just typed in like Definity Principal JavaScript, and like I was confused, like, oh, why isn't it working? And pops up, oh, so maybe I have to install, I have to connect this to that. So it did, and import it, and as you can see, spit out the principal ID. So thanks for coming, everyone. I guess now it's Q&A time.
Thank you, Albert, for that presentation. Please, if you have any question, raise your hand. Okay, go ahead. Go ahead, Zamris. You're muted, Sandri.
unmute.
Go ahead.
Yeah. Okay. Okay. So yeah. Okay. So all of these. So okay, we have Motoko and all of this, description language here between, canisters and all of these interactions. So what I would like to, that, this whole internet computer project or all of this, Motoko languages, is this the best practice, doing that, or, in practice, what would you suggest, to, share data or all of these things?
So for best practices,
Yeah, yeah.
yeah.
So what I wasn't really sure, I have some experience in Rust, and when I seen Motoko and stuff, I was really convinced that it's worth to switch to Motoko. Sorry, it's just my feeling. However, I guess
Can you say that?
Motoko.
Can you say
Yeah,
that sentence again? Sorry, I missed
yeah.
that. What did you
Sorry,
say?
so,
You have
sorry.
a feeling about?
You're just on Motoko, so Rust or Rust language. So we have Motoko, which is indeed more natural for all of internet computer and stuff like that. But what I would like to ask is that this whole interaction between canisters and between these processes is. Is something which is very solid, or is still kind of a flexible, on the air in the internet computer?
Are you saying like like should you make a call? Like should you make a call
Sorry?
from the front end to a canister, or should you call a
No.
canister to call another
It's
canister or
definitely the
something?
back end. It's definitely the back
Yeah,
end on the, yeah.
for that, yeah. Because
So that's what I would like to ask, that it's I see that there are many still flexible things in Motoko language. That's my feeling. I might be wrong, indeed. I might be wrong. I don't know. And it's not so, don't take it wrong. It's not a critiques. It's just not a. So I love the idea. I love all of this. So I think it's a fantastic job that you did. But so my question is really that, in the long term, this Motoko might beat all of those languages that we already have, you believe? Or yeah, I guess you believe.
You mean compared to like what on Ethereum, like the Solidity and I don't know what other
Yeah.
smart
That's what
contract
I mean. Yeah.
platform. Well, I'll say this. To me, I learned a little bit of Solidity too, and that felt like I'm assuming you're familiar with C++ and all and C, and Solidity has a lot of like thinking about memory management, and you also can't like initialize variables. Like how in C it's like really bad practice to just initialize a local variable without like assigning it to like a value, because that causes a lot of problems and apparently has caused a lot of like money issues and hacks and stuff. To me, Motoko feels like Java. Like so if we're comparing, I don't know, like introductory languages, lots of the other smart contract. I'm just gonna say Solidity. I don't want to talk for any of the other ones because I haven't touched them. But Solidity itself, it feels more like C++, and Motoko really feels like like the Java of
Like
smart contract.
JavaScript or something like that.
Well, I don't know about JavaScript. JavaScript's like a weird kind of beast because the type, like you can maybe TypeScript, yeah, but not. But I'm saying like just straight up Java. I think it's or Java or C#. That's what Motoko feels like to me. So Yeah, I guess
Yeah, and,
if you
and
want to
I
compare.
get you. I get you. I really get you now because I am a very hardcore C++ guy who met JavaScript and Motoko. I get you now. So it's yeah, it's an intermediate something, but on the other side, I believe it's yeah, cool. Okay, you
Yeah,
answered my question
and
actually.
then
So
I actually
yeah, there
I
is
didn't.
not a real answer anyway, but
Right,
just a
right.
feeling. Mhm.
Oh, I did want to acknowledge in the comments, Ashton said like, so Motoko does have limitations, and
Mhm.
that's true, and that's why actually I guess so. If we're thinking in terms of like, oh, let's get a beginner coding smart contracts, Motoko would be the way to go. But then, yeah, so I guess Rust and Solidity, like the thing about that is, yeah, you can control more, right? So the more risky the programming language is, like in terms of memory management and stuff like that, the more control you have, which
Yeah,
means less
yeah,
limitation. So I guess, yeah, there's no better. Basically, if you want a beginner to start coding, I would 100% tell them start with. Well, I mean, I would tell them to start with like to actually just, I don't know, pick up any book
yeah.
and figure out the
Yeah,
basics. But yeah,
and that's a wonderful part of you guys that you have really this time you can design all of that. So I and that all that I saw C# coming and things like that. But yeah,
right.
and this rocks for me actually. I might not be a professional programmer of you, but this whole ICP, yeah, that's cool. Okay, so that was my
Right.
question, or you answered, and
Oh, cool, cool.
I'm just
Cool.
listening to.
No, thanks for your input.
Yeah.
I
Thanks,
like
guys.
having conversations. So yeah, yeah.
And just okay. Last sentence is from me is that this whole idea is fantastic. So I can't believe that this can fail. I just met this half year ago, my friend, but love this. Okay, I'm stopping. So just go to someone else and stop. Sorry.
Yeah,
Right.
no worries.
I'll let the.
Thank you,
Yeah, that was.
Saunders.
Yeah, thanks, man.
Any other question? Okay, it seems that we don't have any more questions. In that case, then let's end the lecture. Thank you very much, Albert, and see you guys. Oh, we have one. Christian.
Hi, Chris. Go ahead.
Okay, I have a question, but it doesn't really concern what we were talking about. It is about different case. When I was programming for my core project, when you define an array of that contain two different variables, how to access exactly the memory of one of those variables?
Oh yeah. So I'll pull up the documentation. Show you. Oh yeah. I don't want that. So wait. I'll just wait right here. Let's define.
I put an
An
example
array.
in the comment you
Oh, in the chat.
right in the chat, yes.
Private stable var token URI.
If I want to access that and directly token ID, how can I do that? Because I've already tried everything that I know, but I don't know how to access directly token ID.
T dot. So I'm gonna have to see more
Okay.
context because that looks like, so you did private stable.
Okay. Mm,
Yeah, maybe are you in the Discord? Can I?
yes.
Yeah, and then maybe I can help you in there.
Okay, later on. Okay.
Yeah, so just so I can see the entire code.
Okay, thank you.
Oh, I see a question about oh, well, someone asked about. I think it's clarifying the question, but that's us. I'll help him in the Discord. But in that Java comparison, are we still seeing emergence of movement and ground? Oh, I'm just talking about the feel of the language. Um, Not really. I mean, yeah, there is like an npm of IC that's DFX. So I guess kind of. But I was talking more about like just like the syntax, like the beauty of it. Yeah. So. All right.